Imagine a future where you had infinite willpower, where if you just decided to do something that took a lot of work, a lot of effort, all you had to do was decide it, and then you would do it and stick to it. Imagine never losing sleep to worry, never dwelling on something that you didn't want to stress about. What if you could just learn more faster? Now, these may sound like science fiction things, but gauging by the current pace of neuroscience, these are going to become reality, and some of them within our lifetimes. Now, we've learned more about the brain in the past 10 years than in the previous 10,000, which is exciting for a multitude of reasons, not least of which is to imagine where we'll be 10 years from now. But we're beginning to understand how the things that are going on inside the brain translate into our human experiences. Still, we're farther away from answering the human-level questions than I would like for us to be. I mean, think about it. We can't really do very much about the crippling neurodegenerative diseases like Alzheimer's and dementia. We can do very little to adequately treat psychological disorders. And these are principally because we don't fully understand why they're being caused. And on the flip side, and the part of neuroscience that I'm particularly fascinated with, is the excellence in the brain. You know, what's going on when you're feeling curious or creative? What is that process when you hear an idea and it sticks with you? You suddenly begin to have conversations about it, and those conversations evolve into collaborations, and over time, those collaborations turn into real actions, new projects, new companies, or even just a friendship. And what's going on in the brain when that happens? We don't know yet. But thanks to modern neuroscience, I think we will have answers to these questions and answers to questions that we can't even imagine yet. So let's just do a whirlwind overview tour of what's going on in the brain. So this is a brain, very similar to the one that you have in your head. They're slightly different from one person to the next, but it's made of about 80 billion neurons. Give or take, a few. They change throughout your lifetime. And those neurons are connected through a vast network. Now, in this visualization that came from University of California in San Francisco, they integrated a number of different imaging technologies. And what you see is real visualization. So those orange wires that are connecting different regions, they're kind of like the undersea internet data cables. This is hundreds of thousands or millions of cells. And they're sending electrical impulses that's regional connectivity within the brain. And those impulses are visualized by little dots of light. And then the little sparkles on the outside of the brain, that's different populations of cells firing at different frequencies. Now, the cells in your brain, they have what's called different, like alpha, beta, gamma, delta, different frequency firing patterns, and those correlate to different cognitive states, right? So maybe you're drowsy, maybe you're attentive. That is reflected by the activity within your brain. And at this scale, we're beginning to understand how connectivity translates to changes in function. Oh, for example, the Human Connectome Project scanned hundreds of brains. They did control brains, and then they scanned the brains of patients with autism. And they found a reduced flexibility in communication between different parts of the brains that are associated with changing tasks, changing cognitive tasks. Now, this is one of many discoveries that they made, and in fact, there are many more to be made. And they did something interesting, and that I think we'll start seeing in neuroscience and many other fields of science, and that's that they're crowdsourcing more discoveries. So they have taken their data and they're putting it online and inviting computer scientists, hackers, even amateur coders to help them parse through it and make new discoveries. Now, as far as making discoveries go, we have whole new realms of complexity with which we can make more discoveries. For example, all the way down. So that first brain that you saw, that was macro scale. It's like looking at Earth from space without a zoom lens. Now we're going to go in 10,000 times, 100,000 times to look at the individual cells. Now, these are neurons, 3 neurons, that are actually found in the retina of a mouse. And you have a number of layers of neurons in the back of your eye that pre-process lots of information before it even gets sent into the brain. Now, these neurons have intricate branches, and you can see that they look similar to trees, except the branches of neurons get narrower and wider, and they stretch out vast distances. In fact, if you lined up all the branches of all the neurons in your brain end to end, they would stretch from the Earth to the moon 10 times. And that's only counting one point in time, which is important to think about longer time frames, because the nature of neurons is to connect through junctions known as synapses, one of which we're seeing here. Now, there are something like 100 trillion synapses in your brain, and they're not static, they're changing all the time. In fact, if you remember anything from TEDx today or anything from yesterday or anything in life at all, it's because your brain grew lots of new synapses, and the coordinated electrical and chemical activity flowing through this physical network of connections among neurons in your brain, that's what allows you to understand, to perceive, to have perspective, to have memories, and to understand the world. Now, at this realm, this is nanoscale resolution, and this is the field in which I work. The level of resolution is literally we are taking images of little tiny volumes of brain. Each pixel is like 16 nanometers, and we analyze these images with artificial intelligence, with computer software, to try to recognize 3D objects from volumes of images, and those 3D objects are neurons. And what we're trying to do is decipher the 3D structure of neurons so that we can, first of all, classify cell types, so we don't even know how many types of cells there are in the brain, which is amazing when you think about it. We can land on Mars and we could image atoms, but we don't even know whether there's 1,000 types of cells or 10,000 types of cells in our own heads. Tremendous opportunity, in my opinion. But so I work at this scale, and it's called connectomics, so studying synaptic neural circuitry within the brain. And one caveat of this scale is that the ability to image the brain in ultra-high resolution with electron microscopes has rapidly outpaced any software that allows us to analyze it, to the effect of it takes us tens of hours to map one neuron. One neuron among 80 billion, and you can't just map one brain. Even with Moore's law applied to that, it would take us 50 years before we were even able to map one human brain within 1 year. So in parallel to continuing to improve software, applying machine learning and building better computer vision models, we're also starting to crowdsource neuroscience in a project called EyeWire. It's a game to map the brain. Quite literally, we've taken lab software that originated at MIT and turned it into a 3D puzzle game. That's a browser-based game that anyone, anywhere with an internet connection can play. So this is a screen capture of the game itself. That thing that you see rotating in the background, that's actually a neuron. It's a real neuron, and it's a nanoscale resolution again, and it's one among hundreds of cells that have been reconstructed by the gamers in EyeWire. Now, EyeWire, the players range from 13 to 86 years old, and actually we have one of our top 100 EyeWire players in the world is here right now, Kyle, Icy Cuber. I don't know where you are because it's so bright. He's back there. Yes, Kyle is a freshman at Grissom High School, and he's one of the top neuron mappers in the world. This is amazing, and this has never before been possible. So in the game, when you actually go and hit start playing, you're given a little 3D cube. Now that's a tiny volume of brain. And as you scroll through that cube, you'd see there's a little blue thing, and it looks like kind of a snapped off blobby tree branch. That's a little piece of a branch of a neuron. And as I'm scrolling through, you see these little gray outlines. Those are cell membranes. They're cross-sections of neuron branches. And what you are trying to do in the game is simply to map a branch of a neuron from one side of the cube to the other. Now, you do it sort of by coloring inside the lines, but when you color, you actually add a 3D chunk. It's complicated, so you can go to EyeWire and check it out. But the gist of it is that you're mapping neuron branches across little cubes, and the system assesses people's accuracy in real time, and if the majority of accurate players map the branch from one side of the cube to exit at the same side, then the system will spawn a new cube directly adjacent to it. And in this manner, cube by cube by cube, branch by branch, cell by cell, we're starting to reconstruct the actual 3D circuitry and to understand the wires of perception. Now, this is important. This is fundamental science, because if we don't even know how many types of cells there are in the brain, we certainly don't know how they're connected. And if we don't even know how they're connected, then how can we understand how miswirings result in disease? And EyeWire is the first of many projects. It's actually not the first of this realm called citizen science, but there are a number of citizen science games, things like Folded and Eterna, where researchers are putting their data, putting their bottlenecks online and inviting the general public to help. And I think it is a fundamental shift in the scientific method. It's kind of a catch-22 of this modern age of exponential innovation. We can generate data so much faster than we can analyze it. And consequently, labs are inviting people from a multitude of disciplines to help make discoveries. So in EyeWire, not only do our players range across a wide variety of ages, but they're stay-at-home soccer moms, they're retired grandmothers, they're sculptors, dentists, neurosurgeons. We have people from all walks of life who, at least in EyeWire, have two things in common. They like playing puzzle games, and they have an interest in the brain. And right now, EyeWire is called EyeWire, E-Y-E-W-I-R-E, because we're literally mapping the wiring in the back of the eye. But we've recently embarked on a new project where we will be mapping cortex, gray matter, to understand how the things that a mammal sees are actually translated and processed within the proper brain and the visual cortex. And EyeWire, very similar to the idea of bringing multitudes of people to help researchers make scientific discoveries, our team as a whole is pretty much mostly not neuroscientists. We have physicists, we have script writers, we have audio engineers, graphic designers, and then you have me, which is a complete anomaly. I am not a neuroscientist, as I said. It's completely ironic that I run a neuroscience project because I'm not really formally much of anything because I don't even have a college degree. So one might ask, how did that happen? I often ask myself this, and I'm not entirely sure. I think it's partly because I'm a little strange, and I'm, like to have side projects, and I love to learn and be out there. But there are three kind of life hack habits that I tend to employ on a regular basis that I think do contribute to a little bit of the strange trajectory that I've had, and that I hope maybe if other people would try to employ them, we might have more people from different disciplines applying their great, incredible human brains to solve problems that are outside their traditional set. So, number one, and anyone who knows me will know that I am obsessed with side projects. Work without pay on side projects you're passionate about. So you may or may not know that all the people who organize events like this TEDx, they're volunteers. They're not getting paid. I personally love doing projects that I'm interested in, and I don't care whether I get paid for them. I know a lot of folks, would prefer to have a contract and have a set, term of employment and figure out how they're going to get paid at market rate. I don't care at all. If I find something that really fascinates me and that tweaks my curiosity, then I just want to get involved in it, and that's enough. The reward along the way is connecting with people and taking action on things that I'm passionate about. And I'm very fortunate now that I work in a job that I love, and I think if I was an aristocrat and I didn't have to work, I'd still do about the exact same thing. But I don't know if everyone is in that boat. And I think that taking action, even if it's just 5 minutes here or there on something that you really care about, it can help you find the things that really do matter to you. And eventually, at least for me, many of the projects that I started working on without getting paid have evolved into projects that I get paid to do. So there's one little life hack from me. 2, when you read something impressive, write to the author. This is a huge one for me. I love to read science and technology articles, and yes, I do read a lot of nature papers. But anytime I have a question or a curiosity about something that I read that really struck home with me, I love to reach out to the author and start a conversation, a dialogue with them. And you'd be surprised, actually, how many authors write you back, almost all of them, actually. But then when you start thinking about it, you realize, well, these people put a huge amount of effort, of passion, and research into concocting this article that they're putting online. And probably there are a few things that they enjoy more than having a random person on the internet who read their article and loved it to send them a simple thanks, a simple, it made me wonder, or a simple, do you have more resources? And I will add to this by saying that I never write to people to complain. It's not, frankly, in my opinion, worth my time to leave a complaint for digital eternity. I don't even leave negative reviews on Yelp. There's plenty of people who will do that. I'm not one of them. I'm purely, I'd like to think, a rationally optimistic person. And this has been a great way to build new friendships, new collaboration, new business partnerships, and just, frankly, interesting conversations around ideas that I find fascinating with people who have a similar interest in a topic that I love. And finally, I am a very pro-risk person. It is not easy for me, always, to be pro-risk. But But when I'm struggling with it, this is the thought frame that I put my mind in. I think, if I'm weighing particularly a difficult decision that I'm having a hard time making myself say yes to, I think, in 5 years, am I going to look back and wish that I did this? Am I going to regret that I didn't do this in 5 years? And if the answer is yes, then I have to do it. And I'm going to give you one story that exemplifies this, and that's of TED. I know Everett mentioned before I came on stage that, we wanted to do this big event. And, when I first got involved with TEDxHuntsville, I was like, Everett, we're going to do a huge thing. We're going to have a giant conference. I came up with this big hurdle of TED that in order to have more than 100 people at your event, you have to go to TED. Like TED, big TED, the TED where Bill Gates is and everything. It's crazy. People go to that. You can just fill out an application and then go. But me, I was poor, and I'm still kind of poor, but I'm less poor. But applications were closed. It seemed completely out of the question. So I reached out to other TEDx organizers in the area, asked them if they would be our licensee for TEDxHuntsville so we could have more than 100 audience members, so we could fly in speakers and all this jazz. They all said no, except for Todd Martin, who runs TEDx Atlanta, and he drove over to have a 3-hour lunch with us. And on his way home from lunch, he sent me a text. He's like, you have to go to TED. Just do everything in your power to get there. It will fundamentally change your life. And this mentor encouraged me to do something extremely risky. Then he wrote letters and got me in, and then he and my boyfriend Will sponsored me, let me have the money that I needed to get to TED. And I literally bought a one-way ticket to England. I had to couch surf when I was at TED because I had no money. I tried to fly home standby, but it was the same day that British schools got out and I was stuck at Heathrow. My parents had to buy me a one-way ticket home. It was a cluster. It was disaster. As far as, I literally overdrafted my bank account. That's how bad it was. But while I may have been poor when it comes to money, I became rich in experiences. I met editors of magazines. I met an astronaut. I met, sustainability directors for Fortune 500 companies. And I met Sebastian Sung, the computational neuroscience professor at MIT who was giving a talk about the brain, who started EyeWire, the company that I now run. EyeWire, that I originally reconnected with him because I saw that he had started EyeWire, and I wrote him an email saying how awesome I thought it was. And then a couple hours later, I offered to help him and introduce him to some designers. And over time, my involvement with TEDx, with the TEDx Music Project, even crowdsourcing health with Sterling Health, it all combined to build me this expertise, this background in crowdsourcing that you literally couldn't even study in schools at the time. And that's how I got to where I am. It's just a part of this long journey. So I would encourage you that if you're weighing a risky decision now, or if you encounter one in the future, I hope that you are the big risk taker and the dream maker so that your future becomes one that's wilder than you could ever imagine. Thank you.